Example 4.19. Jimmy has to pay 442 ringgit and 21 cents every month to settle a loan of 10,000 at 6% compounded monthly. Find the number of payments he has to make. So Jimmy here has to pay 442 ringgit point 21 cents every month, but he don't know for how long, because the payment was made to settle a loan of 10,000, right? The principal of 10,000 plus 6% interest compounded monthly. So how long is actually that Jimmy need to pay for his loan? To answer this, right, let's look whether we know that this is actually a case of annuity. 443.21 every month. So equal payment at equal interval of time, annuity, obviously. But then, which formula? Whether it can be solved by using future value formula or present value formula. So we'll see what is actually information that is provided, and we'll determine which formula that can be used. Okay, so we have the first one. Jimmy has to pay this value. Obviously, this is the value of R, which is the equal the periodic payment, okay, every month, to settle a loan of 10,000. So the loan is actually 10,000, or in other words, the original value is 10,000. And we can also say that the present value is 10,000. So Jimmy actually made a loan of 10,000. Basically, we have the value of A, and 6% compounded monthly is actually the value of I. So to answer this, we'll need to use the formula of present value, because we have the present value of 10,000. So 10,000, and the monthly payment is 443.21. 443.21. Right? And then the value of I is actually 6% compounded monthly. So we have 0.06 over 12. Okay? 0.06 over 12 over here. And N is actually the thing that we want to look at. For how long? So when we have this kind of question where N, where the unknown value is take a form of power, right? Remember in our pre-calculus knowledge, right? We know that to solve for N that is in the form of power, we need to put it down by using a log function. So let's do it one by one. So we have this, right? We can divide these two. Okay. So 10,000 divide by 443.21 and equal to this, right? Equal to, we can actually open the bracket because we already moved the R. Wait. Okay, so it should be like this. So $10,000 over 443.21, right? You get 22.56267, okay, equal to this. Now we can actually times this value with this. So times it with 0.06 over 12. Okay, so you get 0.112813, okay, equal to this, right? Now we can settle for 1 here can be settled, right? Just move it to the left side. So minus 1. So negative, right? We have negative 0.888719 equal to this. Okay, so negative and negative, right? Solve it, become positive. Okay, now let's try to bring down the n. Negative n here, let's try to bring it down and put a log function. So it is just like this, right? We just put log 0.88719, okay, equal to negative n log with this. Negative n log this. And when we have already bring down the n, so we can actually solve everything inside here. So n is equal to this log 0.88719 divided by this. Okay, so negative n equal to this, right? I just copied it down. See, okay, and this, right? Let's try to calculate for this. 0.06 over 12 plus 1, so 1.005. So divide with log 1.005. So let's try to calculate it. So we have log 0.88719 over log 1.005. Okay, it gives you negative n equal to negative 23.99. So because of our n is actually in a form of number of times the payment to be made, it cannot be in a form of decimal, so we should always round it up. We always round it up. So we cancel the negative, and 23.99 is actually equal to 24. So Jimmy need to pay 24 times, right? 24 months. So basically the payment that need to be made is for 2 years.